Good morning, good afternoon, good evening, everyone. Welcome on the next Learn Grasshopper live session. Now we are continuing a workshop series about Tekla and Grasshopper, how to use Tekla Live Link and how to use Tekla Drawing Link. And today I have amazing guests like top of the top. We have Sebastian, Gabriel, and Greg. Hello, guys. Can you hear me?
Yes.
Hi, Chris.
Hello,
All
Chris.
good.
Exactly.
Yeah,
Hello.
we are a little bit before our start, so we are using this occasion that we have all legends in the one place. So please let us know if you can hear us well. We will start in just like eight minutes. Already some people are here. We have Tobiasz. Nice to see Tobiasz. Hello from Poland. Just let us know, Tobiasz, if you can hear us well and if you can see a presentation. So yeah, starting from the top. So we have Gabriel Navas with us, based in Scotland. Am I right?
Hi. Yes.
And so how long have you been working for Trimble? And I know that you have additional job in addition to Trimble, that you work for Ministry of Bridges.
Yes, Chris. So I work with Trimble for 7 years now, in about last February, and I am the product for the Ministry of Bridges YouTube channel. I'm not very active, but I'll be back one of these days. I'll be back, and I have lots of material to put online.
And this hoodie is not just by mistake. So you're really promoting like a bridge. So you are
Yes.
the guy who is responsible for bridge designing in Trimble. If someone from the world is having problems, so they can contact you. How is it working?
Yes, exactly like that. So I'm here at Trimble to push for bridge development. So bridge tools, helping our areas, resellers, clients, or potential clients, everything to do with the bridges and their parties. So the infra side of structures, So that's my job. And don't show this hoodie to Trimble marketing, because I recovered the red from the old Tekla Structures.
We have Sebastian with us, and Sebastian is wearing Trimble. Are you wearing Trimble hoodie?
Yeah, I'm covering for you, Gabriel, so we'll at least have some branding if it can show there.
So we have it clear. And Gabriel, you are also a Grasshopper user.
Yes, I am very proudly. I started looking into Grasshopper when I was working for AECOM, well, that was 8 years ago, and I've learned the basics. And within my limitations, as I always say, so I'm quite humble regarding that. So within my limitations, I start doing really cool stuff with Grasshopper. Yeah.
And I saw some work that you also started with the drawing link. And about speaking of drawing link, we have Greg. So hello, Greg. Greg from Poland, near Poznań. Am I
Hello.
right?
Exactly. That's my location. It's a pleasure to be here. I always love to be a part of your workshops, Chris, and together with such great colleagues, experts, I believe that it will be valuable workshop for everyone. But
Before start, I was thinking maybe just we should change that from the workshop to hackathon. Maybe we should make some components cool. Like we have 1.5 hour with these guys. We could make a whole new ribbon for Tekla bridge creation. That will be maybe for the next one.
maybe, but I think that idea is, Chris, you can get some great, brilliant ideas from your shoulders. So I think that some kind of a hackathon for the Grasshopper community around the Tekla would be great.
This is the good idea for you who are already watching. If you will be interested in joining kind of hackathon for Tekla, Grasshopper Tekla Live Link, so yeah, we can do that. I think it's possible. For sure, we'll get McNeil support, Trimble support. So maybe we should change that. So for those who are seeing Greg for the first time, he's the guy standing back Grasshopper Tekla drawing link. So in his free time, he developed amazing plugin for Grasshopper that connects with Tekla drawing, and you can finally automate the drawing creation process. And I'm glad to have him here. So he is going to show this amazing workflow. And the last but not least, Sebastian. We have already comments the live link Yoda. So hello, Yoda. Nice to have you. I think like most of people are here are Tekla users and know Grasshopper, so for sure they are familiar with your face. Just a funny thing, today I tried to find your different picture from the face photo, and when I just wrote Sebastian Lindholm and just show some pictures of the Formula F1. No, sorry, it was Rider. It was WRC, right? Motor.
Yeah,
Motor
exactly. Yeah, he's my nemesis because he's actually from almost the same town as I grew up in.
Oh, really?
With the same
But not family.
name. No, and a racing driver. So not family, no. But it meant that, for example, when I first got my phone, he's older and he was already famous then. So people would used to call me and ask for, can you come and do this, a bachelor party ride for us, for example. And that would have been awesome. I didn't dare to accept, but.
And how long have you been working for Trimble, and where actually everything started with Grasshopper?
Yeah, I've been with Trimble, I think, almost 15 years, or it was Tekla back then. And the Grasshopper work, it starts to get quite old as well, 2016, 2017, probably, when we started. But already back then, we had customers that were using Grasshopper, integrating with Tekla Structures, and we saw what kind of amazing work they were doing, but they just didn't want to tell us how they were doing it, so we decided to try and create our own integration.
And being good so far, and you are 100% on it, or do you also work on other stuff in Trimble?
Yeah, there are bits and pieces of other, like mostly extensions and plugins, but I'd say nowadays it's probably 80% Grasshopper. So, and less of that is the actual development, because as it's gotten quite popular, we also get a lot more requests for support. So,
and new components and requests for new components. Always requests for new components.
Yeah, and that's the fun part, of course. And I like the community in that sense, that people are really eager to reach out and ask for things, and we're trying to comply.
Perfect. Okay, we have already on time. So we have David. Hello, David. Hello, Dota. Hello, Ibrahim. Hello, everyone. So let's start. I will share my screen. So let's go to see it. So hello, everyone. Hello, Birger. So great to see also some students. Yeah, so we are live on Facebook, LinkedIn, and YouTube. And as I always, if you can leave a like and subscribe the channel, so it will help me a lot to make more of this kind of workshop, or maybe hackathons in the future. So let's start today's workshop. We aim into 100 minutes, not more than 2 hours. We have some limitation, and we don't want to make that workshop too long. So as always, recordings will be available to watch later. We are recording it, and link will be sent to all registered users. So at learngrasshopper.com Tekla bridge drawing or after the scanning the code, you can register and you will be sure to get all the recordings. And also we are going to share Grasshopper files and the presentation. So today, Sebastian is going to present how to use Grasshopper for the 3D modeling, and then we are going to jump to Gabriel presentation. He is going to introduce about making drawings in Tekla Structures, and then we will jump into Greg presentation about how to automate creation process creation process of drawings. And as always, I'm seeing all your question, whatever. If you are watching that from LinkedIn, Facebook, or YouTube, you can just write. In the between, we are going to have Q&A session at the end, but if you're going to have in the between question, I will try also to ask guys about that. So 3 things that benefits from this workshop. First, we're going to show this fully automated drawing creation in Tekla Structures. And it's a fun part because Greg is going to show that you don't have to create your 3D model from Grasshopper. You can just create with your normal tools in Tekla, or you can also create that with the bridge creator, and then you can automate that with Grasshopper. So we will show this full parametric approach to bridge creation, and as I already said that, we are going to share with you all the Grasshopper files, which I think is really, really cool. So this series is, we are continuing. I started this Tekla workshop in 2024. We have really successful workshops that are still available to watch and go through materials. This year we had already 2 sessions. First with Oscar about how to use Tekla for prefabrication, and one with Joel about drawings. We talked already about drawings, but in this one we talked about rebar drawings. For those who are seeing me for the first time, my name is Chris. I'm now working 100% as an educator, online educator, and my aim is to transform engineer work into fun with use of programming. Last year, together with Greg, we started Grasshopper in Tekla training. So we gather more than 200 Tekla super users that we are going through all the components that we have in the Tekla live link and in the Tekla drawing link. At the end of this presentation, I'm going to share more details how to join. I would like to just say that recruitment for the 2nd edition is coming really soon. And at the end of this presentation, I will tell you exactly when it's going to be posted and be live. So you can now save a spot at grasshopperintekla.com, and just remember that number of places is limited as it was before, to not to make this group too big. Okay, let's go to today's presentation. I already presented these 3 gentlemen that know everything about Tekla Grasshopper. And today we are going to focus on bridge creation. So let's jump just straight to Sebastian presentation. I'm going to just swap the monitor, so I think we can see already your screen. And yeah, so let's start, Sebastian, what we can see and how to create this beautiful bridge with Grasshopper.
Perfect. Yeah, thanks, Chris. So this is the case study we're going to do today. The bridge that you see on screen here, it's been created by Gabriel. It's based on a real location on a point cloud scan, if I understood correctly. But the bridge is something that then Gabriel has created using the Tekla Bridge Creator tool. So I'm just going to quickly pop up that tool on the screen in case you haven't seen it. So this is not Grasshopper based. It's our own tool for creating bridges based on sections, and you can do quite complicated stuff with it. For example, this bridge was fully created with that tool. And in this case, maybe it's not an overly complicated bridge. It's your pretty, like, don't want to say basic, but a normal bridge. So it's straight and it's got some piers and so on. And a key point here, which Chris already mentioned, is that we don't really, for like Greg's part, when he starts with his drawing production, it doesn't matter how this bridge was created. So in this case, it was Bridge Creator, but you could have modeled it manually in Tekla, or maybe using IFC conversion to get in some reference models and build it that way. But of course, since this is a Grasshopper webinar, we want to show you how you can do something like this using Grasshopper. So that's the plan now for the next section.
And just quick question. As far as I know, Bridge Creator is available in Tekla already as a built-in tool into Tekla 2024. Am I right?
Yeah, it should be included, and Gabriel might correct me if I'm wrong, but it should be included in the installation with the bridge role. Otherwise, it's probably on Tekla Warehouse. But yeah, so starting in Grasshopper, let me just see if I can get these screens a bit bigger, or windows. So this is the definition that will ultimately generate our bridge. And we have a couple of key parts here. So what we want to start with is to get the road alignment. And this could be something that maybe a curve we have in Rhino. It could come from a CAD file. Maybe it could come from an Excel file with coordinates that we then just interpolate through. In this case, we have a polyline in Tekla Structures. So we can just use this one here as our reference line. And then let's see what we got.
So just for someone who is first time seeing Grasshopper and Rhino, so Rhino works a little bit as an AutoCAD, so you can import their DVG files as normally as an import. So if you have your road line in the DVG format is a perfect, but as Sebastian mentioned, you can use also coordinates, X, Y, and Z coordinates, but also for Grasshopper, you have some plugins to import land XML files. So it's also possible to import land XML files.
Yeah, that's a good point. In this case, however, we did get that polyline from Tekla Structures, and we see it here as the green curve. And we also get a preview of the bridge that we're going to create, or the bridge that the script generates. It doesn't yet create anything in Tekla Structures because I haven't activated those components. But anyway, once we have the road alignment, the next task is then to define our stations, like the interesting locations along the alignment, like where the bridge starts and where it ends, and so on, which we do here using just number sliders. They could as well come from somewhere else, of course, from your Excel sheets, for example. So we have the start, the end location, the location of the piers, the length of the abutment, and so on, as well as some stations here for the different parts of the abutments. And from all this, we just compile some lists of numbers. At this stage, it's just like the location along any road line. Where do we want certain things to appear?
And just sorry to interrupt. Just one question: is there any thumb rule about the millimeters? Because I see that you are defining everything in millimeters. Is that as a golden rule that we have in Tekla Grasshopper world?
Yeah, millimeters or meters work for bridges. I like to use millimeters just because it makes it easier with profiles and stuff when you want to get really exact. Of course, for your stations, maybe you would like to define them in meters, and that's fine. Then you just use meter as units in Rhino and preferably in Tekla as well. But even if you have different units in Tekla and Rhino, they will still get converted the right way. So if we had meters in Rhino and this defined in meters, we can still have our Tekla models in millimeters. But for consistency, I'm just using millimeters for everything here.
And if you are based in the North America, you can change that for inches, right, and feet?
Yeah, you can do inches and feet for stuff in Grasshopper. Then you just need to be aware that once you get to stuff like parametric Tekla profiles and some certain like types of offsets and stuff, right now they still need to be a millimeter from Grasshopper. And you'll quickly learn then if you use the wrong unit, then everything gets scaled really interestingly. So you might need to do some custom scaling in Grasshopper before entering certain values, and that's something we're trying to think about the workarounds for. But it's possible to use feet and inches as well.
Yeah, I think it's in Rhino 8 come new components in Grasshopper about the convert unit. It's really simple to use. I don't know.
Yeah, indeed.
Yeah, this one. Yeah, convert unit. So it's a source, and it's so you can choose whatever kind of unit you have,
right,
and it's going to scale that. So maybe it can be helpful.
Yeah, this would definitely be handy when you have something in inches and you need millimeters for Tekla. So that's a good tip. So what we do then, because we have this list of numbers, we need to know like where along the road line do they appear, and for that we're doing these transformations. So it translates those numbers into actual frames along the road alignment. We have the start, some sections or frames for the abutments. Then we're adding some extra sections here or frames at the support, because we want to be able to modify the depth of the profile at these frames. And next, if we just continue the high level stuff, we will define a set of profiles. So this will be the profile of your bridge deck, but also the profiles for the different pieces of the abutment and so on. And they can be defined just here in the XY plane. And
okay, but I think we have to explain a little bit more what we are seeing, because maybe for you it's easy to see the section, but I see lots of sections. So if you can just explain a little bit further what we are seeing on this plan.
Yeah, I will go a bit more into detail about it, how it works in a minute. I think the point at this stage is just that we're defining in the XY plane all the different sections and profiles we want to use for the bridge. And I'll show them in a bit more detail in a moment. But just the high level right now is that we have then our sections, we had all those frames along the road alignment. At this point, we haven't actually generated the bridge. This is what we have. And then we want to move those sections onto the alignment. So you see how we get them here for the deck, for example. And then we do a simple loft through everything. And we have something solid that we can start sending to Tekla Structures. And I'll show you that in a minute. But before that, let's take one example here for the deck to see how it works in a bit more detail. So going up here, we have again the road alignment. That's the first step. In the second step, we were defining those stations, those numbers. So here we have the start mileage or chainage and the end. And then at the third stage, we had those transformations. So if we connect the start and end, you can see that here along the bridge deck, we will get the start of the deck where it should appear. And remember, this is just a preview underneath. So this is what we actually have at this point.
So we until this stage, all these numbers can be also defined in the Excel spreadsheet. Like every bridge designer.
Exactly. Yeah. So this doesn't need to come from within Grasshopper. You can link this to an Excel component, for example. And we can see the start frame there, and we have an end frame at the other end of the supposed deck. And then we get to that fourth step about the profile. So before looking at the profiles we had further down in the script, we can just for this example use any profile from Tekla's profile catalog. So these are all the predefined profiles or your own parametric profiles that we have in Tekla Structures. And I went ahead and just found a double T profile here, which is parametric. This is the profile name that I extracted to a panel. And you can see here it's TT, and then we have these parameters. The first one will be the depth of the profile or the height. Then we have the width, and then other parameters that define the shape of that double T profile. And if you want to see it in Rhino, we can use the profile contour component. And that will display it then here in the XY plane. So we see that's the section that we want to work with. And now we want to move this section to where we had those 2 points, those 2 frames along the road alignment. And we can do that with this orient component. So then you can see they appear here.
So for those who don't know what orient does, so actually it's moving and rotating the profile at the same time. So there is an orientation from one plane to another.
Yeah. And the source plane is the XY plane. If we go into those details, well, the XY plane where we had that initial profile, and the target will then be calculated based on our road line and the location on that road line. And equivalently, we can do this in a slightly different way using the transform component. Then we use the transform output here and the input geometry. And this will actually produce exactly the same output. But the reason I like to do it this way is that we can then reuse these transformations if we want to extrude the parapets or the railings or something else using those same stations.
And it's much faster, right?
Yeah, rather than doing this orient like many times, you can just do it once and then use those transformations. There are some kind of transformation matrices underneath this that needs to be calculated only once if you do it this way.
So the general workflow is always when that you are generating all the cross section in the near 0 point on the XY plane, and then you are rotating that to exact position. So everything starts from the zero coordinates.
Yeah, that's what I find is the most like convenient, because you'll see in a moment when we start defining those the actual profile how it makes more sense to be near the origin rather than trying to imagine points in space. So at this stage we have those two profiles aligned here, and then we just need to loft them together using the loft component, and we get that deck which we can make solid with the cap component. And at this point now we can try to bring it into Tekla Structures to see what it looks like over there. So just rearranging a bit again. Let me turn on that, and we will bring it over as a Tekla item. So this is a kind of generic object type. It's just a polymesh, so it means that we can take any geometry from Rhino and just bring it over to Tekla as it is. So this is the first iteration of the bridge deck that we get in Tekla Structures. So the next thing we want to do is maybe look at the pile or the pier locations. We can see that in Gabriel's model, we need to make it a bit thicker. And to do that, we need to define more frames here at the bulge. And that we did already in the station. We calculated more locations, those extra frames, which we can see here. And those then translate into those extra profiles. So the deck itself didn't change anything yet, because we are just copying the same profile over and over. But then instead of using just this single profile, maybe we can use this list of different profiles. And that means that now each profile can be individually defined in this list. And they are parametric. So the first one here, let's leave those as they are, but then start increasing the depth of the profile. So in this list, we could change the numbers here to increase the depth in the first parameter and see what happens. So now you can see how it actually changed. We get higher profiles the farther we go, and you see also here that we get that curvature down towards the first pier.
And I think we have a good question from Mikołaj. Do you also define what happens between those frames section? Is being interpolated linearly between them from one to another?
Yeah, you can choose the interpolation type here in the lofting options. We can set like, do we want to have it normal, which I think is a smooth interpolation, or then a straight, which is actually preferable in this case, and I can change it already here maybe, because then then we get the straight deck over here, and only once we start changing the profile, it will then change. And the reason why it's better to use straight here is that if we want to make it smoother, we can instead increase the number of sections we have just with a parameter. And in Tekla, it will always be interpolated anyway with a straight interpolation. If you have something smooth in Rhino, internal in Tekla, it will be represented as a straight polymesh. Even though you don't see it in the model, but internally, Tekla doesn't work with like actual mathematical curves. It will always be some kind of interpolation. So we might as well like take control of it over here and just set the number of sections we will have to get as smooth transition as we want to. But anyway,
good answer. So yeah, so definitely increasing the number of sections will help to increase the quality of this if this is a curve. So just to make the interpolation.
But now, as you saw, I'm entering these values manually, and of course I don't want to do that. I want to have them calculated based on whatever inputs I have. So here at the stations, we are also based on whatever like transition curve we want to have between the support and the bridge deck. We can then use the expression component to calculate values for each of those sections based on these parameters. So that's what we've done here, and the output will be then just this desired depth at each of the sections that you saw previously. And that's again a list of heights, a list of numbers. And we can then bring those numbers in here. You see here is the same list. And now we like to use those values instead of my manual values in this profile string. And to do that, I'm going to use the replace text component. And the input will be then the profile string. And here you can see that I changed actually the first parameter to a tag that says width. And I could use any name here. It just needs to be something that I can then search for and replace with my actual values. So that's what I'm doing here. We're replacing the width with the list of values here. And the output will then be a new list of profiles. And now you can see that my heights, my actual heights are being inserted here in the list.
Mm-hmm.
And those then get applied to each and every section. And now we start to get the actual bulge that we're looking for here. So now I'll remove this one and go to our actual bridge deck. So get rid of that. And you saw that I used a profile from Tekla Structures. Like I said, you can sketch your own profile. But here I decided that we're going to try to use a profile that's made entirely in Grasshopper instead. So if I just look at one section, you can see that this cluster here will generate the green outline that we have. And of course, being parametric, so we can change the values and get different kinds of sections. But staying with that first one, I'll quickly show what it looks like inside. And this looks a bit messy at first because of all the wires, but it really boils down to quite simple things. So we have all those inputs, the width, the thickness, and so on. And then we do some simple arithmetic just to calculate each and every coordinate for the points here. So for example, to get the third point here, we have made some calculations to get the x coordinate and the y coordinate, all based on those inputs we had for the deck thickness and width and so on. So that way we generate every point here and we then collect them in order. And at the end, we can get out the polyline around the section. So that's what's happening here. And because we had more than one height that we want to work with, we can insert that as a list. It comes there, the same list that we saw previously. But now it works on this cluster, and we can see all these profiles being generated now on top of each other. So the output will be a list of different profiles.
So only the height is a difference between only one parameter. The rest, or all the rest parameters are the same.
Yeah, the rest work the same at this stage. You can modify other parameters as well, of course, in the same way. And here there's some interactivity between, I think, the width of the support and the height of the support that you can see. So it does something else inside the cluster. But this is like, depending on your situation, you might want to do the calculations before, or then you can do it inside. Like, I won't go into detail about this, but this will affect the width of the actual support as the height increases.
And just one question. Daniel asks, why do you prefer a Tekla item instead of beam in Tekla? So maybe this is I think you have added variable cross sections in the newest. So maybe you can take it, tell more about that.
Yeah, there are variable cross sections with, I think, up to 10 different cross sections in the API at least, and that's supported by Grasshopper. But in this example, when we want this smooth transition, let me actually generate the bridge deck so we can see what it will look like in Tekla. So we are taking all those profiles like we saw here, placing them in the correct locations, and then loft between them as in the previous example. And in the end, we can generate this item in Tekla. And the reason why we prefer to create this as an item is mostly it's about that variable cross section, which you might be able to replicate with certain like variable cross section beam profiles. But then when you have, like if you have a lot of different sections, then you will run into some kind of limit. The second thing is that as soon as this starts to get curved, like now it's straight, but if it was over here, and especially if it's double curved, then there's no way to control like the crossfall at the far end of that polybeam. So you can set the rotation at the start, but the end it will be whatever it is based on whatever algorithm Tekla uses internally. So this way of instead defining lots of cross section and lofting between them, we always know at every point like exactly what the crossfall is. So that's one other reason for using items.
Yeah, like we have also comment from Gabriel. Whenever you have the curved clotoids or super elevation, so the item it will be way to go. If you have simple bridge deck, so beam, it will be good enough. Especially that you can also have some variable cross section, but in the other cases, the deck it will be the best solution.
Yeah.
Okay.
But we'll get back into the discussion about items versus beams in a moment. First, I'm just going to show that we're doing the parapets in the same way. So here we start at different stations and we use a different section, but otherwise it's exactly the same idea. And actually the same will go for the abutments. So looking here at the abutments, we have, let's compare it here to Tekla. Even though this looks more complicated, they can actually be created easily as just extrusions as well. So this side, for example, it has the same section here as over there. It's just a bit higher. So it's very similar to what we're doing with the bridge deck in that sense. So again, we are just defining here a set of profiles that we want to extrude through these stations. And now the stations are a bit different. We are focusing here on the start and end of the bridge rather than the middle. And that way we can generate all the geometry for the abutments. And let me just enable them so we can see them in Tekla Structures as well. And that will be your abutments. But even here we are doing some things like this is, for example, created as a concrete beam with a profile. So whenever you can, it's good to use beams. And that will be even more evident in the next part where we focus on the railing. So over here, we are...
Just if you can just if you can generate the railings, we have just 2 minutes left for that one. We have to move on. So if you can generate railings and show how railings are created, because you are using the same methodology, or you're
so
using
this is
components?
different because here we are using beams. And the reason for that, so we identify the edges of the deck, and then we are using beams with a profile rather than creating them as items. And the reason is because we have, for example, these middle pieces here, there are hundreds of them. So if we actually made them as items, which maybe could be easier, just boxes from Rhino, then the model would still perform okay. But the issue is then with modifying them and generating them through the API, which can become really slow. So then we prefer to instead create these beams, which have a rectangular profile, and it's then offset, and that's all controlled by Grasshopper. And they are actual beam objects, which are a lot faster than items. So a combination is good. And then I'll just quickly show the third way of inserting objects in this example. And for that, we're going to look at the piers. So here, Gabriel has actually, instead of creating these objects individually, he's compiled a custom component to do it. And a custom component in Tekla is just a collection of like simple objects, or can be complex objects, and they have some relation to each other and can have some logic and so on. So parametric intelligent groups of objects. So for example, here we have actually, these are just slabs that have been extruded using the profile thickness. But then Gabriel has grouped them together into this intelligent component. And we have that available in Tekla for insertion manually. So I could just click it here and select wherever I want to place it. And Tekla will then place those objects relative to my location. And we then need to rotate them to match the bridge. And doing that from Grasshopper is straightforward. So we calculate those points where we want to insert them. And then we just tell Grasshopper that this is the name of the component we want to use, which matches what we had in Tekla. And at those points, it can then just insert those peers.
With a good
and
rotation.
And it calculates the rotation then based on the tangent and of the road alignment and sets that as an attribute for the component. Same way that we would do here manually in Tekla, but now we're automating it. So that idea goes here for the piles as well. These are also custom components. And this is a good use of like components because we can make them quite complicated. Like I said, just looking inside this, we can see that Gabriel has added some reinforcement into them and some logic. And then he just saves everything as a single like custom component. And then we use Grasshopper to place it like 5 times or 100 times or 1,000 times. So that's a good combination of use of the power of Tekla with the power of Grasshopper. Because doing all this manual in Grasshopper, it's possible, but it requires a lot of coding. It might be just quicker to reinforce it using the tools in Tekla and then copy that around using Grasshopper. So to finish up, now that I know all my locations, these were, by the way, the bearings underneath, same idea as the piles. I know all those locations, I know my peers, so I can generate a grid. And once that's done, we have something which is very similar to what Gabriel did using Bridge Creator.
Yeah, even in Bridge Creator, we have items, right? So this is not it's the same output what we are getting.
Yeah, exactly. So I use the same object type. So in Bridge Creator, these are also items, but this is a beam. So you will have the same object types in this example as what Bridge Creator produced.
And we are going to share this script so you can try for yourself. What about the components? Do users going to have this component or they for columns? Or maybe
that's true. So
maybe we have to attach them.
We can share Gabriel's model perhaps, or then attach just the components, export them, but they will be needed, because the only thing Grasshopper looks for is are these names. So if it's a standard Tekla component available out of the box, then it will work like in any Tekla model. But if they have been made specific for a project and are available only in a single model, then we need to share them.
Yeah, Gabriel, can you hear us?
Yes, I can.
Yes, perfect. You are with us. Can we share this component with users?
Yes, we can. Yeah, I'll compile everything. I'll share the component. Yeah.
Perfect. Thank you, Sebastian, for this amazing script. It's really great to see that the same workflow can be used for the bridge and also abutment. I think sometimes it can be like this switch. It's like, okay, this is the same methodology that can be used for also retaining walls, or not only bridges. Everything that is aligning, going aligned with the road curve. Okay. Let's go to the second part. Thank you, Sebastian. Sebastian's going to come back to Q&A session that we are going to have. But now let's go and talk about the second part. Now we have this 3D model. Everything great, but at the end we have to produce drawings, right? Still, maybe Norway is so lucky that they don't have to produce the mass of drawings, but in the rest of the world, we have to still produce drawings. So Gabriel, if you can just make an introduction to all the properties and settings, what we are having, a little bit different types of drawings. So before we are jumping into creating drawings with Grasshopper, that is Greg is going to present in a while. So Gabriel, just make the introduction to the world of drawings.
Yeah, Thanks, Chris, and I will. And I can tell you that model-based projects that are kind of not relying in 2D traditional drawings any longer, just based on models, or with a couple of drawings like in Finland. So Norway, they're going all in, but it's happening too in the USA, right? So there are some Department of Transportation in US that are looking into the models and trying to build based on the models. So they still have some growing pain, but they will get there. So maybe we are not aiming for the what Norway is doing, no drawings at all, but can we optimize the drawings and reduce the number of drawings to deliver our projects? So I'm going to speak maybe for 3 or 4 minutes just to tell you a couple of things about drawings in Tekla Structures before, because Greg needs that information to have a good output. So I'll go here. Let's move that. So the core principle and associativity in Tekla Structures is to do that the 3D model is a single source of information. So everything that the model has is going to appear in the drawing unless it's filtered out, right? So if you have information in your drawing, some lines that represent a beam that you don't want, you cannot delete that line. You can hide the line, but you cannot delete objects from the drawing itself. You need to go to the model and delete if you don't want that beam, for instance. So the drawings are intelligent to the view of the model, and the objects are linked to that model object. And highlight the changes with symbols is to do with this. In this view here on the left side, you see that okay, you have some dimensions there, but they are not connected. So if the object changes, something wrong is going to happen with it. Is not linked. For the right hand side, you see this nail there that represents the dimension is linked, is associated with that corner of the object. If the object changed, changes, then the dimension will update. And then when we have changes inside the model and you open the drawing, Tekla will tell you temporarily for a couple of times when you open the drawing after, we'll put some revision clouds in pink, as you can see here in the middle image. And then you can add your ref cloud if necessary. Anyway, yes?
And this pink, in this pink annotation, it's not visible, right? For
It's
those
not
who are
visible when
seeing.
you print the drawings. No,
Print it,
no,
no.
it's just to support if you want to put ref clouds or not. As a drafter, and I start doing drawings by hand in that time, it's the most horrible thing that we need to do is to put ref clouds every time we issue a new version of the drawing. All the information I'm showing here, I took from the support.tekla.com. Then if you search for drawings, you have that information. Now, drawing types, what Greg is going to do is GAs, general arrangement. That is the majority of our drawings, and they show the overall structure. So could be a foundation plan, could be a top plan, whatever, abutments in this case, talking about bridges, and so on. So this is what Greg is going to control from Grasshopper, is this type of drawings, but we have more type of drawings. Workshop drawings, single part on the left hand side. Tekla has an amazing capability to create automatic drawings like this. So, and our steel fabricators, clients, they take advantage from it. On the right hand side, we have assembly drawings. Then we have cast unit drawings. A cast unit drawing is a concrete.
Gabriel, sorry,
yes?
we have some troubles with your voice. If you can just speak slower.
Slower.
I think you're
right.
you're speaking. You're too fast. So we have time for your presentation.
Okay. Okay.
Just maybe some troubles with the internet, but yeah, just keep going, but
okay,
a bit
Chris.
slower, so it will be good.
Yeah. I think I'm too eager to listen for what Greg is having to show. So, right. So I'm too eager. So I'll slow down a little bit. Our cast unit drawings. They can be cast in place or precast. We have rebar, and this intelligent drawing and can be the drawing itself or can be the bar bending or both. It's great, for instance, to take advantage from the cloning capability of Tekla Structures, because if you have this type of beam, any similar beam you can clone. So the first drawing you can take a while to produce a drawing, and then all the other ones is just a couple of minutes, and you can clone those drawings. The last type of drawings that I have to present is multi-drawing. And as the name says, you can see here n assemblies in the same drawing. If you place a table with bill of quantities inside this drawing, everything that inside this drawing is going to appear into that bill of quantities. Quite handy. So you produce your assembly drawings separately, and then you join into one multi-drawing, and you can even add the bill of material. So 3 levels of control. This is very important and takes me back when I've learned Tekla Structures in Helsinki, that I really needed to understand before even I start doing drawings, to understand these 3 levels of control: drawing level, view level, and object level. And I'm going to repeat this a couple of times. If you don't know Tekla, or if you don't produce drawings, you need to understand this, because then when you go to Grasshopper to produce your drawings controlled by Grasshopper, you need to know, right? So, and I guess Greg is feeding and telling in the script some information about the drawing level and view level, and probably not object level. So the drawing level, you can control your frame and all the type of views you want and the settings of those views, right? And then, of course, the view level controls the look of the objects, maybe the filter and all those settings. And then the object level is when you go inside the view, and you have a line over there that from a beam, for instance, and you have all that information there. But you try to control from 1, 2, and then just a couple of times number 3, but you should avoid to change object level settings. And I'm going to tell you why in the next slide. Workflow and advanced settings. Right. As I said, top-down workflow, drawing, view, object. I hope this makes sense. And then the view level can be overridden. Let's say that usually I start doing the drawing by creating a plan, right? And then suppose I want, instead of the top plan, I want the foundation plan. I change my settings of that view that was top plan to foundation plan. And then all the settings changes. So it's the same view, but I change the view level. So it can be overridden. But at the object level, if then I go to one line and say, I want this line inside the view red, and then I change the view level, then that red line, it will be stay there forever, right? So you cannot be overridden, because it will lose the link. So try and please avoid to change at object level unless you don't have any other option. And then, as much as possible, look into this website, support.tekla.com, to detailed object level settings. You see this right-hand side image. You can configure all your objects that appear into those views with this way, with these settings. So here the example is every part that's a column is going to be blue. So now you can imagine you can do whatever you want here at the detailed object level box. So you can have your view controlled, the settings for some general stuff, but then for the objects, everything controlled with the detailed object level settings. Worthwhile to go and have a look there. And the right-hand side, drawing level, view level, object level. And mainly that's going to be the takeaway of this very short introduction of drawings for Tekla Structures. So first, what you see in the drawing is what is in the model. Even when we're talking about, let's say, a tag for the reinforcement, let's say the tag says 10 bars, B 20, and then maybe the spacing, right? Something like that. And if you don't want 10 bars, you want 12, you're not going to type 12. You go back into the model, you change the model, and then you come back to the drawing and the tag is updated. If you type anything inside the drawing, apart from nodes, you lose that beam. So remember always about that. You're doing beam, so no dummy information inside the model. Master these 3 levels that I spoke before. So drawing level, view level, object level. And then follow that top-down workflow and apply those settings. At last, preparation. It will be much better if you have someone in the office that does that preparation for you, right? So let's say the BIM manager,
all
or
this boring work, right?
right. So it's great. When I started, I just copy all the settings from WSP in Finland and was great. So my settings were perfect. And then I started adapting, right? Could be a little bit hard work on setting up the settings for your company or a client, specific client. But then after a while, it is great because everything is going to look the way you expect, right? And then when Greg takes that or you take that information and you want to drive the drawings from Grasshopper, it's a breeze because you just need to know the name of the setting to apply to that view, for instance. And this is my short presentation, and let's watch more cool stuff.
Yeah, let's invite. Thank you, Gabriel. Let's invite
Okay.
Greg to the presentation. Greg, can you hear us?
Yes, of course. And yeah, I would like to say thank you for Gabriel because I strongly believe that what he presented is the most crucial one. And those 3 levels of settings for the drawings are the must have. And also those detailed object level settings, they are the hidden gem. They are not used in every company, but they provide a lot of possibilities to customize how different elements in your drawing should look like. But yeah, okay. Let's go with the drawing, and that will be the reverse process Sebastian showed, because during Sebastian part, he showed that he start at the global XY near the origin, and then he transform the geometry into the alignment along the curve of the bridge. And here the situation is quite opposite, because we start with some 3D geometry inside of Tekla. And as you said, Chris, previously, it doesn't matter if the geometry is coming from the Grasshopper, from Bridge Creator, or was it just modeled by some crazy guy by hand. So the drawing link works when it starts from the Tekla. This is the only necessity. So we have the same model as Gabriel presented, as he prepared, and that script I will try to go through all of those little blocks and try to explain exactly what is happening. And the first thing when you want to create a GA drawing is to try to understand, okay, so what scope, what range of the model I want to present. And here it's quite simple because we want to present that exactly bridge, and we have one model with one bridge. So I already selected all of those parts which are in that model. We can we can always use Sebastian Tekla object pipeline to get it in a different fashion. But I just selected them, and before creation of the GA drawing, it's always good to get some restriction boxes, some bounding box of those objects. So that component is coming from the live link. Because when you will try to create the drawing, it's not only about the operating along the Tekla drawing, the drawing link part. All of those workflows, they heavily rely what Sebastian already developed inside of the live link. So to successfully make your drawing with the help of the Grasshopper, you will combine the superpowers of both of those links. But okay, now I have those bounding boxes, and those are just the very simple geometries, just some boxes. So as you can see for those pies, for example, in Tekla they were rounded, as Sebastian shown already, but here they are just some squares. And this is due to the performance that we don't need to get the exactly detailed meshes for those objects. So
these bounding boxes, they are not representing when you are clicking on the column, for example, with the component selection method. It's not just the blue one, which is
yes, exactly. They are maybe not so visible on the live screen, but you are right. So we have limited the model, but then we should think, okay, so from which side I want to see, what kind of a view I want to create on the GA side. And here there could be a different starting points, but I just started with something quite simple. So I just asked the user, hey, please pick the line. And the line is presented as a blue one. It's just the line along the longitudinal axis. That's all. And those two information are enough to construct the view plane. So that will be the first thing which we want to enable, because here we will just create the plane, which will be our source of how we will see our drawing. And yeah, now probably it is not very visible, but we will just create the elevation view. So we need to think, okay, what kind of a projection we should apply to get our result. So that will be the elevation view. So we will just want to look on our bridge from side. That's the first task. And then when we have the restriction box in the global coordination system and we know from which angle we want to see our bridge, then that's the matter of applying the transformation. And to do that, in the drawing link, there is the simple orient component. This is just the variant of the orient which already was presented by the Sebastian, but it's a little simplified. So here we are getting, as you see, our geometry of those elements, but already projected. So those are transformed to look only on the top view. And that is the main view which you will use inside of Rhino, because almost all of your drawings, they will be oriented in such a way that you will look only on the top one. So we already know, okay, what is the restriction box, how big portion of the model and which coordination system we will use to creation of the drawing. So maybe that's the good time to just create the drawing. And to do that, as already was said by Gabriel, we need to use some kind of a settings. Here I will use just the standard ones, and those are the first tier, the first object settings for the drawing. So let's create the drawing. There is just one flag, and now the drawing will be created and opened. And it's just a dummy drawing without anything, but we already have set up the name and the layout. This is what comes from those settings which are saved before creation. So we have the drawing, we have the view. So now it's time to create the elevation view. And I want to create it in a round, because at first you need to mimic the model view. So as every time when you are dealing with the GA drawings, usually in Tekla, you first have to create some kind of a drawing inside of the 3D space. So here it goes the same. So you have to use some name and mainly describe from which angle you want to see and how big portion of the model it has to use. Then it's time to use some settings for the drawing. For the view, and then let's just create that view. So now the view.
Sorry, just to interrupt. So what you are showing is that almost exactly the same workflow you are having when you are creating it manually.
Exactly. Then you also rotate the view into angle which you would like, or you are creating some view based on the axis. And then when you are creating the GA view, then you are selecting, hey, Tekla, please get that exactly angle, that restriction box into the drawing area. So that happened between those two components. And now we have the elevation view, and that's just the elevation view, nothing fancy. But it will be the base of the next showing of capabilities of the live link, because now I want to place some dimensions. And I thought about that one. So that will be about the foundation. So every time when you have some drawing, you are able to get elements which are visible on that particular drawing. So I will just use those two components. Let's go here. And now I have asked the Tekla, hey Tekla, I have some drawing view and I'm curious what I see there, what is there. So there is the component coming from the drawing link, which will return you the result in a form of key value pair. So it says that, okay, on the drawing, you have some edge chamfers. They are not so significant for us. You see some grid and you also see some part. And if you go into that part, then you will see that in the third branch, we are getting quite a lot of different elements. And as you saw here, that reflect the part. So then with the help of those two components, you are able to get only those parts. If you're interested in the grid, then you are just getting the grid. That's the result. So that combination of those three components is very frequently used in terms of the drawing, because you have to always ask, okay, so what do I exactly see on the view? And maybe if you are following what Sebastian shown for the creation of the whole parametric stuff, then you know what type of objects to expect on which place. But rather you will work just cut it from that modeling part. You will start with Tekla, and then you have to query to filter those things. So here I'm getting some drawing parts, and you can also always look into them by just selecting them. So now I am getting just those. Oops, sorry. It just yeah, it selected all of them, and it took a significant time just selecting them in the view. So maybe it was not the best idea. So let's just wait. Okay, and those are the drawing parts. And now I want to group those elements, because they are now just the drawing elements as you would like to have them, like that. You can change their color, what is visible, so you can tweak their object level settings as Gabriel presented the top down. And it can be done with the help of the drawing link, but as Gabriel said, it is not the best way to do. You should always try to say how the drawing should look like based on the view settings, not the individual elements. Okay, and then I am just going from the drawing part to the model part, and on those model parts I am able to group them based on many different features. So now I will say, hey, you have a list of Tekla objects, and I want to have them grouped by the name. And what does it mean, group by the name? So here under the hood, that component asked every model object, hey Beam, what is your name? Okay, my name is Abatmat, my name is Beering, my name is something, and it grouped it into this key value dictionary. So here we are getting all of those elements grouped by name. Maybe in your case you need to group them by the class. So now they are grouped by classes. Maybe you need to use some report property, then you have to provide that report like that as an input for that component, and you will get the same result as with the grouping by the name. And very often, before placing some level marks, placing some dimensions, you need to group those objects. You need to filter them by some distinguished factors. So I will now go further, because now I have them grouped by the name, and I want to operate only on the name of the foundation. So now I will say, okay, I have all of those elements which are visible on that view, but I need just foundations. So let's go to find only the foundations. And at the beginning, we had a list of a lot of different objects. There were 12 branches, over 900 of different elements. But at the end, we just get 3 of them. And as you saw, as you remember from the Sebastian, there are 3 foundations. So we have
just let me know. Just I'm following. So before you search for the parts, right? Before, in the previous step.
Here I asked the view.
Yeah, for the part. Yeah, and then search the key for the part.
Exactly.
Yeah.
I get all of those elements from view. I converted them to the model objects, and then by my modeling techniques, maybe you are using the class system, maybe name system, maybe some UDA system, we are grouping them to work on the small chunks. Because if you would like to dimension 900 elements at once, it will be very hard to distinguish, okay, so this I need the dimension from the left, this from the right, this from the top. But here you can just decrease the complexity of the task. So I'm getting only the foundations, and then the magic starts, because I have the foundation, those 3 model objects. So with the help of the lifelink, I am able to get the BREP, and those BREPs are referred in the global coordination system, because I am asking the model object. So every time when you work with the drawing, you need to do the transformation from the global coordination system to the view coordination system. And that's the crucial part of every drawing operation. Because here in the drawing, if you would like to insert something, I will try to insert, whatever, then you see that I now get this red arrow pointing to the view X and Y. And those directions, they don't refer to the global ones. They are very specific, they're very unique for that particular view. And every time when you will place something in that view, you have to refer to its internal coordination system. And to do that, you are just asking for the view properties. Hey, please tell me what is the display coordination system? And you use that for orientation of your 3D geometry into that 2D one. So now please look on the top side. We had the 3D B-reps in the global, but now we are getting just their projection exactly the same as within the Tekla. So those three ones, I will now just get it. They are exactly those three elements in the same direction, in the same coordination system. Oh, sorry, I just changed it. I close it. Not. Let's zoom, and here they are. Okay, so but those are still the 3D geometries. So the next thing to create the dimension is to get the shadow of them, to cast some light and get the edges which are visible from the top. So to do that, you are using the B-rep projection border, and and here you see the difference in Rhino. I had the 3D object, and now I just get the polyline which surrounds that. And then the fun part starts, because you have to consider, okay, so from which side I want to create the dimension. And to do that, I will now just say, okay, I had that geometry, I want to get it from left, or maybe from right, or maybe from bottom, or you get the point. So you have to decide, okay, so from which sides I want to create the dimension, I will use it from the bottom. So now those little points, they are the dimension points which you will use inside of the Tekla. So we are almost ready to create the dimension line. And we still miss just one thing, because we need to specify, okay, so where exactly the dimension line should be placed? Because now we know that it should be anchored, associated with the points from the foundation, but we have to find some way to get the free space. And there are a lot of different ideas how to do it, and it all depends on your use case. For that, I know that there won't be any object around the foundation, so I will use just that edge to be moved a little. So now I will enable those components, and you will see that the dimension is created and it's moved based on that setting. So I am getting it in that way, maybe from the right side, maybe from the left, and that's all about the dimensions for.
So what, if you can repeat, what input are necessary for creating the dimension? If you can zoom a little bit more to the component. Yeah, so you need the view, which we are creating. You need the points. And I assume that as you can see, as we can see, it's a data tree. So you are creating three different dimensions.
Yeah, exactly. Those three dimensions are created at once during the one step over that component. So it was run just once.
Yeah, and location. The last one is always when if you are doing that manually. So you have to choose 1 point, second point, and then where middle mouse button and where you are positioning.
Exactly. This is very, very similar to the way how you do it just by hand. So if I will place the dimension, I will pick point, and say where exactly. And as you said, with the middle mouse button, I am just saying, okay, here I want to have the dimension. And
so you just can not too scary. So not too scary all the users that are seeing that you are mimic all the same steps that you are doing manually.
Yeah, because they are needed to have control over the dimension line. Yeah, you need to show, okay, so which points I want to pick and where the dimension line should be placed. Because yeah, here I'm just placing one dimension line per foundation, but in other type of the drawings, there will be multiple of them, and you don't want to create the clutter. So you don't want to have them in one messy space. So that's why you have the control over the placement of that location. So yeah, before doing the drawing, you need to have some imagination how exactly it should look like. So that's always the tricky part. And that was about the thickness. But yeah, here are the grid dimensions, and they are a little more complicated because we have some grid, and I will start exactly the same as previously. So I will ask, hey, view, please tell me what is visible, what is there? And I am getting, as previously, different elements. And now in the keys, as you remember previously, there was no dimension. This is the same view, the elevation view. So now I'm getting, oh, something new has happened, but we will work with the grid. So as well, always, I am limiting the scope of that result only to the grids. And then I am going, okay, please go to the model object. And then with the help of the drawing link, I am asking, okay, so about the drawing, about the grid, what are surfaces are there? What are the labels? What are the all of that stuff which is related to the grid in Tekla? And for that, I will just try to go to the to the perspective. Okay, so now this is the representation of my grid, the surfaces which are related to that one. And I want, as always, to see them, but not in the global, because that's not what I want, but to see them in my view coordination system. So now that's what I see in the view. I see this P3, abutment 2, all of those are represented here. So let's go to the top one, and that will be what I see. Of course, it's a little different representation, but you get the point that those vertical axes, they are reflected by vertical lines. So with the help of the power of the Grasshopper, with the Rhino, we should somehow get those vertical planes axes from all of those planes, and it can be done just by some dot product of those. So I will just enable a few components just before the dimension line to make it a little faster. So you see that now I am getting some points, and those are coming from that one. So here are my points which I want to dimension, and I want to place the dimension line in Tekla. So this is the component which is responsible for creating the dimension line. And now I provided just one location and one branch of those points. So in the result, I just get one single dimension line for all of those distances between. And as always, we can think, okay, should I see that from the top or maybe from the bottom? And here, what is a little different than in the previous is how to get the bounding box, how to find the perfect spot for our dimension. Because previously I was looking only for that part. I was only considering the foundation, but here with the axis, it's not so easy what we should do. So I am using this magenta restriction box, and with the view properties, you can always see, okay, so what part of the 3D space I am seeing in that view. And you can project that. So now that's what I see. This is the pink rectangle coming in Tekla. And okay, so this is the pink rectangle, and I want to have it a little bigger. So I want to create some offset. So then I will just ask, okay, so based on that offset, I want to see what points are visible from the bottom, from top, whatever is your idea for placement. And I am creating the dimension line. And for the dimension line, as Gabriel said, there are 3 levels of settings. And now I provided also this extra dimension line attributes. And this is used for specifying settings different than the standard. So I will now create something red. I will save it as a red one. So now I'm creating in the model directory the red settings for the dimension line. And of course, it doesn't change yet. But if I will use the same settings, so I will provide, hey, Tekla, please create the dimension line, but with those attributes. Then I will get those settings applied. So now the color of that has been changed. If I will not provide anything, then the standard one will be used. So that's about providing the attributes. And as you can see, there are multiple different attributes, both in the live link and the drawing link. You can customize everything, but there is always the question, as already Gabriel raised. Probably always it is better to customize the visual appearance by the view settings and by the detailed object level settings. Those are things where those little tiny combinations of hidden lines, red, green, blue, whatever is your typical duty, should be done. But okay, now I would like to also insert the level marks. So I will just try to place the level marks at the bottom of the pile. Those are also the objects which can be done with the help of the geometry link. So those level marks are, as you can see, customizable. And what is interesting here, I would say that here we see 6 piles probably. There are a lot of them in a line, but we want to place only one level mark because they all have the same bottom line. So yeah, it's just the magic of the Grasshopper. This is why I always like to do something inside of the Grasshopper, because you have those handy geometric components ready from the shelf. So it's why it speeds up the process. And when you deal with many different operations on the view, here I placed the dimension for the foundation, for the grid, for the pies. Then it's always nice to have them directing into one component. And I developed at some time the loop keeper. It's just some type of the data dump. So it will wait until all of those previous workflows will meet to at that point, and only after that it will pass the control for the next one. And that's quite important, because now, as you can see, that view is placed somewhere in the drawing space. It's not what we would like to have. So we want to have some control over the positioning of that view. And that part is done here. So after completion of all of those insertion of the dimensions, level marks, all of that stuff, we are ready to place. And why is that important? Because only after insertion of those elements, you know exactly how big that view is, how much width and height and the drawing space it occupies. So you should always wait until everything will be done on the view level. And after that, let's go to the positioning. And here I am using the positioning like that. I will just enable that. So I'm asking the drawing, hey drawing, please tell me how big you are. So this is the A0. And based on that, I am able to create the anchor point, because I have to know, okay, so where I want to place that view. And I will use that component to place it at the upper left. So I'm providing the point, the anchor, which also reflects the margin for that particular layout. Of course, it's very dependent on your company settings, how big margins you have and how you would like to set up the drawing. But then you are able to just say, okay, how based on what point you want to make that positioning. And for that, only this one makes sense, because I want to have that view in that corner. So that view is now positioned, and let's go. I'm just looking to the time to the next thing. This is the top view positioning, but we still don't have the top view. So then I want to create the second view, because I have the elevation view, and now it's time to think about the top view. And the question is, what is different between those two? We will use exactly the same bounding box, because we want to show all of those elements which the bridge contains of, but the direction, the plane on which we are looking into our objects is different. So that's why I am here creating the different plane, and this is just the top view plane, but that's not the global one, because yeah, we have that bridge aligned not by the global X, global Y, but some different road line. So then I'm just getting the restriction box exactly the same as previously, but now, as you can see, we are looking from top, and if we compare from the previous one, then we were looking from the bottom, from the side. So that's the difference. And now, as previously, we will just insert the view. And as Chris, you said previously, it's very the same as the normal Tekla user would do from the UI. So we have to have this 3D space limited to some area, and also to provide the direction of that view. And then we are able to position that. And I want to have them glued by the edge. So I will use the previous elevation view to position the new one. So now they are just glued by that point, and it worked for that particular case. At any time you can ask which points of the view are located in which area. So then, as already Gabriel mentioned, the foundation view, we will use exactly the same restriction box, but with different settings. So now I will use exactly the same model view here. So I'm looking into the same geometry from the same angle, but with different settings. So now I will use those settings instead of those one. and you need to have them prepared previously. So usually you have some settings here prepared by some magician in your company, or maybe you are that magician. So then it will be much easier. And yeah, let's just create that model view for the foundation. And here it is. And what we can do with the foundation, probably we should place the dimensions for those foundation along the longitudinal axis and perpendicular direction. So here are the dimensions, and as always, it is a little repetitive, I know, but always you start with some view, you are asking, okay, so what is visible there? And you are limiting for the drawing object type which you are looking. If you want to create the reinforcement dimensions, then you don't use the part, but the reinforcement. And as you see, there is quite a lot of different object types which can be placed inside of your drawings. So when you
I see. Sorry to interrupt. I see the pattern that you are using similar components, and actually the part of the script can be just copied here. You don't have to create everything connection from scratch.
Yes, exactly. That part is the perfect candidate for some cluster. That's something which is reused in every time, because you always start with the view and then you are thinking, okay, so what is visible there? Of course, there is the alternative approach, a little faster in terms of the execution time, that you know that in that view you will see something. But yeah, for the sake of that webinar, I am not having strong assumptions. I'm always asking the view, hey, please tell me what is there. So then I'm grouping by the name, and here the name will be a little different because I want to see only the foundation. And what other names are visible here? So we had the abutment, foundation, pier, pile. Those objects are visible in that, and truly they are. But I want to work only on those objects. So yeah, I am just limiting those elements to what I want, and then the same. Convert to brep. Let's see that brep in that particular view. And as you remember, we saw those foundations exactly here, but on that view we saw them from the side, and now we see them from top. Then let's get their borders, so casting the shadow, and then something is going a little differently because I want to have the dimensions from 2 sides, or maybe 3 sides, or maybe 4 sides. And what is now different? Now we enter the complexity of the trees inside of the Grasshopper. So if you want to create those dimensions at one shot, and then you have to properly structure your points as a tree and the location as a tree. And to do it, there are, as always, different ways how you can do, but this is, in my opinion, one of the easiest way. You can also use the series, but maybe not in that case. So I am making some Grasshopper magic just to offset a little from the edges. And yeah, it's just steered by that. So now you see both in the Tekla and both in the Rhino that I am just moving a little further or closer to the dimension edge. And based on that typical schema, you will be able to place the dimensions from whichever side you would like to have. And then there are multiple times when you want to have the dimension link. Normally, as a user, you will just click here and link dimension line, and it will be there. But with the drawing linking, you can do it also by that. So you have to provide a list of elements which should be glued, and that's all. And okay, I see that I'm very close to the end time, so let's look what is there. There is some synchronization as always, and then what is there? Okay, that view is then positioned, so that will be just a little different, just a little, because I will go to that part. Okay, so now, as you can see, the previous way of positioning just to the edge between the top view and the foundation view is not the best, because those views are misfit. Their origin is not exactly at the same place. If you will see those red arrow, then you see that they are not perfectly aligned vertically. So here you can do it by some different way of moving, by some vector. And if you are able to calculate that vector, then it will work. So now I will just move it And now they are aligned how we would like to have them. So let's go further. And then there is some section. So now I want to create the section, the mid-deck section. So I will just go that in a quick way. So now the drawing link created the section here, and it is placed here. And let's see how the section creation looks like. Here we have to provide a little more points because it's about providing the point where the section line should start and where it should end. And yeah, how big of the model area has to be covered. So what is the depth up and down, and there are different things to set up, like the scale name and all of that with what is coming from the section. And I think that for that there is also one thing quite interesting, the deck dimensions, because we saw in Sebastian's presentation that he started with the section of the bridge on the 2D, and then he extruded it through the path with some sections. But here, as you can see, the workflow is exactly the same. So I will ask the section, okay, please tell me what is visible. Please give me just the parts. I will group them by the name because for that model, the names are quite unique one. And then, okay, I want to see only that part which name is deck, because here we have some parapets, we have some railings, but I want to create the dimension only for things which are named deck. And here the difference.
So the naming is really important for all the elements. The naming is
because when people are doing drawings, they just see, oh, I know that this is the deck. I don't have to check the internal name inside of the Tekla. I just see this is the deck. That's all. But for the machine, it's not working like that. You have to guide it and you have to instruct it with some way, like the classes, UDAs, names. Those are the typical ones. And now just, I think, one last thing which is worth to mention, because usually when you deal with Tekla geometries, you are using just convert to brep, but here it all depends on the meshing properties of those elements where they were created as an item. It is configurable on the Rhino side or in the bridge creator, but just please compare the times which are needed to convert to the brep. It's almost half of the second, and convert to mesh. So if you face some bottlenecks in terms of the time, then maybe just let's look if the convert to brep is the source of your problems. If that, then you have to do it with the convert to mesh. And then it goes almost the same. I'm also using the mesh intersection, and yeah, to show that I know that I'm a little after the time, but just last one thing. Please look what we see. Okay, so this is the result, and what I had. I had the whole mesh of that particular deck segment, and I also knew, okay, this is my window, this is my slice of the section which is visible, this one. So I don't want to work on the whole deck section, because if that will be curved, if the geometry will be not just a simple extrusion like here, then I will get too much of the points when I will just get the projection. So with the help of the Rhino geometry engine, you can always ask about the intersection between the whole geometry coming from Tekla and that very slice of the view. Okay, and then I will just move it to create that, and then you will see in Tekla that I am getting those dimensions from the bottom, because that's what I saw, okay, maybe from top, and now those dimensions are from the top. And next, maybe last tip, when you deal with placing multiple dimensions into the same direction, so like that I want to place the dimensions for both, for all the points which breaks the polyline, but also I want to place the overall dimension, then the series component is very handy, because here you can provide the first margin, I would say, the first distance, but also then between the rest of them. So if you have stacked dimensions, a lot of them for some assembly drawing cast unit, then the series works very well. And yeah, I think that we are a little over the time, so
that's good. But you show a lot of, and of course we are going to share, so you can try it with yourself. First, you can generate with Grasshopper what Sebastian prepared and then use the script. Are you going to enable all the components?
Yes.
Hope that nothing will crash it. So we'll see all
Yeah.
the magic. So you can see all the moving stuff. So yeah, as you can see, the workflow it requires some time to create the script. But if you are doing these bridges over and over again, and you are repeating that, so you will see that you can save a lot of time. We have some additional questions, but let's take them after the Q&A session. Okay, Greg?
Sure. Okay.
Sure. Thank you to that presentation. And as always, please share if you have any question to Sebastian and Gabriel. They are going to come back in just one second to us. And just before the Q&A session, if you feel that this Tekla Grasshopper live link and the drawing link is interesting you, so you can take your Tekla structure skills to the next level together with me and Greg, and we will teach you how to build your own tools in Tekla Structures with Grasshopper and tackle your toughest problems and automate boring tasks in Tekla. So as I mentioned at the start, soon we are opening doors to the Grasshopper in Tekla training. We have already more than 200 Tekla super users there. And what is Grasshopper in Tekla training? This is an online training that opens the door for starting automating all the boring and repetitive tasks that you saw today. There's lots of practical knowledge and examples for different Tekla users. We are not just focusing for bridge design as today, but we have steel design, we have industry, we have precast examples as well. We have a supportive community. We are building community where you can ask even the simplest and most silly questions, and made by trainers with experience in teaching, which I think is very important. We have plenty of students. You can find some recommendations from Sveko. We have Stan from who is teaching Tekla. Others I really recommend the Tekla Structure Academy. We have Victor and Eystein, our students there. And the training is based on the practical real case studies. So we have a 16-story high-rise building. We have also a velodrome stadium that you can see prefab and steel elements, racing arena for cycling. And we have also bridge structures as we showed today. This is the agenda for Grasshopper in Tekla training. You can find it in grasshopperinttekla.com/agenda. So you can see we are going through all the components that we have in the live link with the params, advanced elements, reinforcement. We show how to extract and modify elements, how to create your user interface, and which is really important, we have also Greg with us on board, and he is having all the lessons. I think it's almost 20 hours of video recordings, 60 lessons about drawing automation. So it's the best way to learn from someone who created this tool. So recruitment for the second edition starts in May, exactly in 3 weeks. So it's already possible to save your spot, and you are going to save your spot. So you are going to get offer in 3 weeks. I'm going to invite you for opening. So that's it for this session. We are going to a Q&A session. So please write your questions. Next workshop, it will be in next week, in the 14th of May. So I have invited Nathan Luke, and we are going to talk about Tekla and integration with Karamba and Idea Statica. So it will be more about steel connections, steel design, industry, halls, buildings, frames. Really cool workshop, how to connect that analytical software with Tekla and with Idea Statica to make this connection and interact this connection, send this data seamlessly back and forth to Tekla Structures. So I will post the link in the comments, and I will invite Gabriel, Sebastian, and Greg again. So good to see you. Thanks for all the great presentation. Let's go to some question. I saw that there's some question there. Maybe we'll start with Sebastian. Sebastian, you are mostly limited with your time. So here, let's start with this question. Sebastian, are there currently any versions of Tekla Live Link higher than 1.16 available for Tekla 2019 or will such version will be available in the future? So if you can answer that.
Yeah, 1.16 is the last one we released for 2019. And I think it will be the last one we ever release because there has been quite a few API changes. So maintaining those old versions became just too much work. I think 2019 it is out on maintenance also as a Tekla version. So if possible, I would recommend to upgrade to a newer Tekla version for many reasons. But I appreciate in some old projects maybe you're not allowed to do that.
And what is the latest version for the higher version? I saw that I just downloaded today 1.20. Is it official or still 20 is not official? 1.20.
No, 120 is work in progress, but 1.19 is available with, I think Welds was the last big addition there. So that's something you could check out.
Perfect. Thanks for that. Gabriel, we have a question from Rui. Hi, inside Tekla structure, dimensioning rules are possible to use also?
Yes, absolutely. So, and that when I was showing the different types of drawings, and they see all those single drawings and even the assembly drawings. So Tekla can put at the view level, can put dimensions automatically, right? So you can set up lots of things. So I was very happy this webinar was about bridges, right? Because usually bridges, sooner or later we come to a hole, right? So it's okay, we can get automatic dimensions, but then I think it's not going to work for our plan for the deck, right? So what I advise the users to do is I'll paste a link to the support page where shows how to configure those dimensions. You're going to test. Maybe if we're talking about simple, let's say even the foundation plan. So from the drawing link, you can call a specific setting, let's say foundation plan, and then with the dimensions on /D or something like that, and then try to have those dimensions automatic. Because if you can do that, you'll save some coding and still drive the drawing with the drawing from the Grasshopper drawing link, but having some dimensions applied automatically from the view level. For instance, for the elevation, I doubt that the automatic dimensions from Tekla are going to work. So when I created my views, I always take the dimensions off because sooner or later I need to delete dimensions and then it's going to have more work. So I prefer to place those dimensions. But some objects, definitively, you should look at it. And for buildings, yes. So and then again, if you can replicate what Greg shown, right? Taking advantage from dimensions automatic Tekla can place on those views, it's even better, right? So it's good. The solution is there for both ways. So we can cover everything with what Greg has shown, but Tekla can even help that workflow. Sorry about the long answer.
No worries for
Important.
that. We have time. Greg, Mikołaj has a question. Do you also define where the plan view is crossing the structure? Is that through point within the deck or above the deck, or is it done through the thickness of the view?
You have the full control over where the origin of that plane is located. And at the very beginning of my part, I shown the little blue line, which I picked, and the start point of the blue line was the origin of that plan view. If you want to have it above, below, in the middle, it all is up to you. You can set up it however you would like. That was the first step of creating the plane which will be used later for translation and for the creation of those views.
Perfect. Let me see. I posted the link to support Tekla that Gabriel was mentioning, so you can find it on the comments. Let me see. Question to Sebastian, directly question from Victor. If I weld part together in Grasshopper, they are not creating an assembly in Tekla, correct? Why does it work like that? Welding but not assembling.
Good question. I think we need to look at the default behavior there, because it should probably be the same whether you do it manually or through Grasshopper. So if that's really not working as it should, then we'll correct it.
Maybe we can get, if you, Victor, can specify. I'm not sure. Let me check if we have Victor online. But is it true, Sebastian, that is it not welding, not assembling the two pieces?
Yeah, we're not doing like we're not forcing an assembly. So I thought out of the box that it should probably become an assembly. But this is one of the part that's developed by a colleague of mine, so I'll check with him what he thinks. Like I said, it should be reflected.
Okay.
The manual and the Grasshopper way should work the same.
Yeah, we are going to have session in 2 weeks, right? About new features in the Tekla 2025. So for sure, we are going to talk more about welds and rebar sets.
Absolutely.
Okay, cool. Ram, what is the course fee, please? The pricing for the course, it will be released in 3 weeks where the official starts. So just subscribe for the waiting list, and then you're going to get the best offer. Let me see. Gabriel from Ahmed. Is there a way to make spacings between dimension line equal?
I'm trying to understand the question. Is try to make spacings between dimension lines equal. Does anyone I don't understand the question. Sorry. Is there a way to make spacing between dimensions line equal? I don't know if Ahmed refers the spacing between the dimension and the
vertical.
object. Yes, because we saw Greg feeding the distance from the points until the dimension goes. So if you have always the same, just one input, and you feed that into the boxes when it's time to place, it will be always, let's say in CAD will be 1 centimeter, let's say, right? And all your dimensions will be 1 centimeter from the object. But again, I'm not sure if I'm answering the question.
I think it's more related that if you have several dimensions on top of each other, if you can make spacing between them equal. I think it's more referred to do it one like more automatic tool that you don't have to move it every single on top of each other, but just aligning them with equal distance.
So I guess with Grasshopper, it's just a matter of having one and then one more value to add to the second one, and so on and so on. But yeah. So the answer is yes. I'm sorry about
that. Yeah. In Grasshopper, like Greg, you can confirm that, or maybe not confirm.
Yeah, there is also the separate component just for the case when the dimensions are not created by the Grasshopper, but they are from the dimensioning rules or by hand. Then there is a separate component inside of the drawing link, which is exactly tailored for that case to make them equal. Because if someone is coming from the CAD world, then they usually expect that it will be at the same order.
Yeah. That's okay. Okay, let's go to another question for Sebastian. Have you encountered issue in plugin in version 18 where exact spacing for guideline attributes in rebar sets it's not working? For me, inputting a list of spacing doesn't work, though it does it rebar group.
I have not encountered anything like this, but that's not to say that it isn't true. There might be some bugs there. Yeah, I would need to try and recreate this and then see. if it's working as it should. Maybe we can address it then in 2 weeks' time in the next webinar.
Yeah, that would be great. It maybe something changed in grid lines in Tekla 2025.
Possible, yeah.
Okay, we'll check that if you are going to be together with us in 2 weeks, so we can check it further. Let me see more questions. Sergey, it will be great if all of you make a Guru Live also for reinforcement in Tekla. We already made that, so let me see. Maybe I will share my screen. I already had it in 2024 last year. It's still available. Automate your reinforcement in Tekla using Grasshopper. So it was workshop 2 hours. So I will paste the link so you can about the rebar group. And also some weeks ago, I had one with Joel. Let me see. I'm going to show you this one. So it's also it was about a rebar drawing automation. So you can find both of them and register, so you can watch it. It's still available to watch it for free. All right, thanks for that. Let me see. Do we have any more questions? Maybe Sebastian and Gabriel. Maybe you have some questions to Greg. It's the first time that we have a live session together. Sebastian, maybe you've been inspired with some new ideas for components in LiveLink.
Yeah. I mean, first of all, I just need to say how much I appreciate Greg doing this, like in his actual spare time, which is just amazing. Because pretty much from the get-go, we started getting questions about, could you please include drawings in the LiveLink? And I never got around to do it because I'm quite scared of drawings and the drawing API. At least though I've done stuff with it, but I really don't like it. So I admire that you have pushed through and gotten all those clunky workarounds that we need to use, because the API is really not all that easy to use in the drawing side. So, I mean, a question would be like, how do you keep going? Like, what keeps you motivated? Like I said, I don't envy you working with the drawing API, but you managed to do it.
Yeah, I would say that the first thing is I recalled at the very beginning of our meeting when Gabriel said about the Ministry of Bridges, that for me, I think that it was the first ever time to see the Grasshopper work for Tekla. And later on your webinar, Chris and Sebastian, you presented all of those details and all of that magic related to the creation of the geometry. Those it always look amazing. And if I think how much time I would spend just by trying to code it without the Grasshopper, just with the pure C#, oh man, it would be a nightmare. So that's why I just wanted to be a part of that world, and the drawings are something which I work every day. That's the Tekla API is something which I usually touch, I would say. And there, as you said, there are a few things which can be done a little different. So that's why I am trying to push further the drawing link, because then more people will utilize the Tekla drawing API. So those tickets on your priority list will be a little higher. That's my hope. We will see.
Okay, I know, Sebastian, that you have to go. So last question for you, and you are free to go. So I'm interested in how to conventionally create a variable cross-section. Is there a component that allows you to easily change, for example, the width of the deck?
So I'm thinking, are we talking within Grasshopper now, maybe? Because we're asking about a component that allows to change
conveniently. Yeah.
Like, I mean,
so
if
there
you
is
use...
no out. Yeah, sorry. Continue.
Yeah, I was just thinking that there is no, like, if you use a parametric variable cross-section component or profile from Tekla Structures, you can drive that by just replacing the parameter values in the text string, like I showed. And I appreciate that's maybe what you mean, that it's not really convenient. But I don't think that there's out of the box at least a better option right now. Of course, you can code that logic into a cluster and have your inputs for each of the parameter values in that profile string, and maybe that becomes more user friendly then.
Yeah, I agree. There is no out-of-box solution for every type of bridge, but you can create your own logic, and every bridge section is different. Depends on company who is designing, company that is going to build that. So yeah, unfortunately, you have to build that your own logic, but it's not that difficult to do. Okay, Sebastian, thank you for that. We have some still questions, but I think most of them are for Greg and Gabriel. So thank you, Sebastian, for taking time with us, and see you in 2 weeks.
Yeah, thanks everyone. See you.
Greg, question to you. I'm not sure if this topic was erased, but is drawing link going to become soon the Tekla warehouse? What is the status there?
I wanted to make it as a surprise on our workshop at the beginning of next month, but now, yeah. So yes, it is going to be available on the Tekla warehouse, and that's related to the change how the tool is deployed. Because there was also the question about that previously it was the GHA, the Grasshopper assembly, and now it is the DLL, because now the governance about the loading of the correct link version, both for the live part and for the drawing part, is done by Sebastian GH loader. So that's why it will be available on the warehouse at the beginning of the next month.
Yeah. So this is a really good news. So let's make it official on our next workshop. So no worries. So you are lucky to be here to hear the announce. And question about the board behind you. I already in the backstage before we started this workshop, I also asked about that, Greg. Is everything already done? Or is that
no, and we are very close to the mid of this year, and then I would expect that almost half of them will be marked as done, but unfortunately it's not the case. Still there are some things which are quite big ones, some related to the drawing link, some to some other side projects, but yeah, it always have to somehow fit into some other live activities, because yeah, it's always nice to have some live.
Yeah, and speaking about the DLL, Rens just wrote that the GitHub, there are DLL files, not the GHH files available. And this is going to be updated for new updates, only DLL files, right?
Exactly. Because now, after the changes coming from the Sebastian, you can have multiple versions of the live link and the drawing link in the Grasshopper directory. So there is no need to manually removing, pasting the right one for your current Tekla version. And that is the great development coming from Sebastian, but it also requires the change of the extension for those files. So that makes some things a little more problematic in terms of downloading them from the web. So the step forward to the Tekla warehouse is the next natural one.
Yeah. Gabriel, we have from Laura a question. I have been using Tekla for 15 years, and being able to create non-standard objects is really great through Grasshopper. Do I unfortunately need Rhino to use it on Tekla? What will be your answer?
I suppose not, because with Bridge Creator, and as you've seen today, you can create very complex objects following the road and even the parabolic variation on the soffit of the deck. So you can use that, and even the abutment, if the abutment is in curve, you can extrude that with Bridge Creator. So as I always say, is that Grasshopper has a very specific space in helping for modelers to become more and more efficient, taking into account that the drafter modeler profession is coming to an end. right? So let's say 60% worldwide of these guys are now, and girls, of course, are now engineers by trade, right? They are not drafters. And they don't want to be modeling or doing drawings in Tekla. They want to do calculations, right? So that is why we saw first in the Nordics, coming down through Europe, and now even in USA that is happening. And if we go to Australia, it's happening the same. So even East Europe, even from many years already, they are all engineers. So we need to have tools like Bridge Creator that can help, let's say, the traditional modeler, even an engineer. But if you come with a background of Grasshopper and engineering and so on, right, you might want to do your extrusions with Rhino Grasshopper. But if you stick into Tekla, my objective is you need to have the same tools there. So it's different, but you have the same end to reach the same end. So, but yeah, you can do it with look at
so you
the
can do it
latest
with
Bridge Creator.
But you can do it. Also, Grasshopper will give you more flexibility. So it's not that you have to use Grasshopper. You can use Tekla also tools for that. But you will be not that unhappy with the Rhino, because Rhino, the cost of Rhino is for the lifetime access. It doesn't cost a lot, and it can give you more flexibility, not with just non-standard elements, but also connecting with different tools, and for example, automating drawings as it's shown. Greg, Luca asked, is it possible to extract developed sections, elevations along a road alignment? I think it was during your presentation question, but...
Yeah, I'm thinking about the extract word. How should I understand? Because you can create sections along the straight line, along the curve. That's what Tekla offers. That's what the drawing link offers. So not sure about the word extract, because for me, extract is just getting those sections and elevations from Tekla and placing them somewhere else. But maybe I'm wrong. So if Luca, maybe Gabriel, you.
Yeah, Greg, there are two options for this question. The first one, I don't like the answer, right, is if Luca is talking about the developed section longitudinally along the road. Let's imagine a snake viaduct, right? So for that, Luca, no. So you need to check the Tekla warehouse. There is an extension section along path or view along path, something like that, and is a workaround. So you need to look at that. If Luca is referring to and because this is happening lately, some clients are asking for it. If you are talking about, right, we have that long deck as you have seen, and now I want cross sections every 5 meters, right? So a slice of 1 millimeter thick along the deck, starting at station, I don't know, 1000 and finishing 1100 every 5 meters. So Bridge Creator can do that already, and it'll give you slices of along the road. If with Grasshopper you can do whatever you want, right? So because if the question comes for the Grasshopper side, it's yes immediately, but not the longitudinal snake elevation or section, unfortunately. So that is very complex. So you need to go to workaround. Yeah.
Rens asked about the DLL file. So Greg sent a message. If you go to this app data with the percentage Grasshopper libraries, or you can also go into Grasshopper and search for special folders, and you can find there the link.
Yeah, now I just had some idea that some time ago I recorded the video about the installation of the drawing link, and it is referring to the old one. And Chris, am I correct that you recorded the video about the new way for the live link?
Yeah. Yes. Yes.
So that will point how the new way of working with those DLL files look like. So maybe you can just pause that video because it was very good, very good for me.
Yes, I am going to make that. Let me see. I'm going to share my screen like that. Yes.
Oh,
so here
exactly.
it's ultimate guide to install Grasshopper Tekla Live Link 2025. So I will also paste that. So here is for the live link, but the rules applies for the drawing link as well. Let me see. Just 2 more questions, and I'm going to make you free. Chris, the Tekla Live Link and the Automating Drawing Creation are 2 different training courses, right? Can I access both with the same link above? So actually, we make that as a one training, and Grasshopper in Tekla drawing live link training is a part of the live link training. So if you're going to register, so you are registering and you are accessing only one training, which includes both of them. Link to webinar, it will be sent to everyone who registers. So Ibrahim, I sent the link so you can register there. Okay, perfect. Great comments. Thank you very much, Sebastian, Gabriel, Greg, for the session. Thanks you, Chris, for hosting. Lots of good comments. Thank you, guys. It was a very informative webinar. See you in 2 weeks. Also see you in 1 week. I'm going to have a session about with Nathan about Idea Statica and Tekla. So again, thank you very much. Gabriel, do you see the power of automation of the drawing creation? I saw some of your tries, so you are already on it.
Oh yes, since the very first second that I've seen that it's a great advantage for everyone that is doing a Grasshopper, and then just keeping on that workflow. And now even for if as we've shown today, even if the model has been modeled just inside Tekla, you can take advantage from it. I really see it since the very first second advantage here. Great job, Greg. It's amazing what you're doing in part-time. So I don't know how you sleep, what, 2 hours a day maybe, right?
No, it's not. It's not so bad.
People are saying not only me and Gabriel are thankful for you, like we have great job, guys. This is really interesting. Sergey, thank you, all of you. So this is just a confirmation how good work you are doing, Greg. So again, thanks very much. For those who are interested in Grasshopper in Tekla training, just register in the waiting list. And yeah, we are going to have next month in June a session with Greg. So please, if you are on the mailing list, you are going to get all the information. Looking forward to this one. Maybe we will talk about a little bit different aspects of Tekla drawing link. Gabriel, thank you for being with us. Thank you for representing Trimble.
Thank you.
Good to see Trimble that is supporting that and is with us. And yeah, hope you in the next one, and hope that Ministry of Bridges channel will be still active and you are going to record new videos soon.
It will. Thank you. Thank you for having me.
Thank you.
Yeah.
Bye-bye.